today we're going to talk about predicting products of chemical reactions again. And in the first part of this particular set of notes, we're going to focus on single replacement reactions only. Now, in single replacement reactions, if you remember, we start out with an element and a compound, and the element bumps out one of the elements in that compound. And after the reaction, we end up with a different element by itself and a new compound. So we'll see how that plays out in just a minute. But one thing to remember for sure is that when elements start bumping out other elements, metals always bump out metals and nonmetals always bump out nonmetals. So we'll see that in just a moment. Again, we're going to watch for diatomic elements. We're going to find charges for ionic compounds only, not for the elements. The only thing we're going to look for on elements is whether they are diatomic or not. And again, we don't carry over subscripts unless they're part of a polyatomic ion. Now, another thing to think about in these reactions is whether an element actually has the strength to bump out another element. And in order to determine this, we have something called an activity series. Now, this activity series simply lists the metals in order of strength. The strongest is going to be on top, the one that can bump out everything else is lithium. That's going to be our strongest. The weakest is going to be on the bottom. The reason we can find gold in veins and silver in veins and not combined with other elements very often is because it's weak. It just does not have the strength to bump other elements out and form those compounds. So the weakest down there at the bottom is gold. So if we're looking at the difference, for instance, between aluminum and iron, can aluminum bump out iron? Well, here's aluminum, here's iron. Since aluminum is higher on the list, yes, aluminum can bump out iron in a chemical reaction, but it can't happen the other way around. Iron cannot bump out aluminum. Now, we're really not going to get into the situation with the hydrogen from acids and water yet. Since we have not discussed acids yet, we're going to stick with just our ionic compounds. Now, for the activity series of the nonmetals, you don't even really need an activity series because if you look at the periodic table, you'll see that the halogen column is an activity series all its own. Fluorine is the strongest on top, and that's its location on the periodic table as well. Iodine can't bump out anything. It's the weakest, so it's going to be on the bottom. Now, if you start looking at a situation where you're trying to see if iodine will bump out copper, then you're doing something wrong. They're not even on the same list, and that's because copper's a metal and iodine's a nonmetal, and nonmetals will not bump out metals. They'll only bump out other nonmetals. So let's see how this looks in an example. So here's some examples of our single replacement reactions. We've got, first of all, potassium reacting with copper chloride, copper 2 chloride to be exact. Remember, if it's in symbols like this, we can go ahead and write it in words so that for some of us it will make much more sense this way. Copper 2 chloride. When it reacts, remember, we need to make sure we know whether these substances are metals or nonmetals, so we'll know who's trying to bump out who and if they can or not. So potassium is a metal, copper's a metal, chlorine's a nonmetal. That's a gimme in a compound. It's always going to be in that order. The metal's always going to go first, the nonmetal's going to go second. So chlorine's the nonmetal. So in this case, potassium is trying to bump out copper. Can potassium bump out copper? Let's go back here to our list, and we can see in our list that potassium is right here, and we're trying to see whether it will bump out copper or not. Copper's way down here. So potassium is significantly higher on the list. Yes, it can bump out copper. So let's go back to our reaction. Since it will bump it out, Think about who's dancing alone, if you will now. Copper is going to be by itself. Should have had that in green. Copper is going to be by itself. And now potassium is going to be with chlorine. So potassium chloride. Now notice something about that Roman numeral with copper. Now that it's an element, that Roman numeral no longer makes any sense because remember that Roman numeral simply tells us that copper is a +2 ion. So we would not include that when it's an element. So we've got copper plus potassium chloride. And now we can rewrite. We've got potassium plus copper 2 chloride. We're going to react that, and it's going to form copper. And the only thing we need to know about copper is it diatomic? It is not one of our hydrogen 7s, so it is not diatomic. It does not need a 2. The potassium chloride, the skeleton formula, if you will, is just K and Cl. But remember, it's an ionic compound, so what do we need to do? Find charges. We know that potassium's a +1 if we look it up on the table. Chloride's -1. So it does not need any subscripts. So we're good on that one. So now all we need to do, now that we have all of the formulas correct, is to balance it. Make sure you add in these blanks in front. We want to make sure that we don't put any subscripts in to try to balance, or we've just messed up our entire compound formulas. Only in front, only coefficients can be used. So it looks like we've got 2 chlorines on the left and only 1 on the right, so we're going to need to put a 2 here to get our 2 chlorines. That messed up our potassium, so we'll need a 2 here to get our potassiums balanced. It looks like that's balanced now. So there's one reaction. Let's look at the next one. Aluminum nitrate plus magnesium. This is already in words, so we don't need to worry about that part. So labeling this, we know that aluminum nitrate is a compound. Magnesium is an element. And I really should have labeled that right off the bat up here, an element and a compound up here. Notice I put those in blue because I really want them labeled. That's going to be what's going to give us our clue that this is going to be a single replacement reaction, because if we have one element and one compound, single replacement. So now that I know it's single replacement, guys, it's only single replacement reactions that we figure out whether something's a metal or a non-metal. So aluminum is a metal. Nitrate is acting like a non-metal. Keep in mind that nitrate is a polyatomic ion. It ended in an ATE. It's acting as a non-metal here because it's last in this compound. And then magnesium is another metal. So who's trying to bump out who? Magnesium's trying to bump out aluminum. So magnesium is trying to bump out aluminum. That really should have been a blue. So I really want you to show who's trying to bump out who. How do we know whether that's going to happen or not? Going back to our chart. Here's magnesium. Here's aluminum. Looks like magnesium can barely bump out aluminum, but that's good enough. It may be a little bit of a fight, but it is going to be able to bump it out. So what are we going to end up with? We're going to end up with a new compound now. Magnesium is going to now be with nitrate, and the aluminum is going to be off by itself. So let's write that as a formula equation. We've got aluminum, we've got nitrate, there's our skeleton. Remember, we need to find charges. Aluminum's a +3. Look up your polyatomic ion list. Nitrate's a -1. So it looks like we're going to need 3 of those nitrates to balance that formula. Magnesium is an element. Do I need to look up the charge for magnesium? No, I do not. Elements, all we need to know about elements is, are they diatomic? Magnesium is not. It's not one of the hydrogen 7s, so we don't need to put anything after it. Now on the other side, we've got magnesium and nitrate together. Nitrate, NO3 again. Magnesium's a +2. If you look it up, nitrate, it's always a -1. Looks like we're going to need 2 nitrates to balance out this chemical formula. And then aluminum, of course, all we need is its symbol and to decide whether it's diatomic or not, so it's just an element, and it is not. So we've got the correct formula for everything now. All we need now to do is to put these blanks in front and to balance these. And it looks like our nitrates are not balanced. It looks like we need 2 in front of aluminum. There are 3 over on the left and 2 on the right, so we always can cross those 2s and 3s. So it looks like we end up with 6 nitrates on each side now. And looks like now we have 2 aluminums we need to account for and 3 magnesiums. So there's the balancing for that particular one. So let's look now at barium fluoride plus iodine. And first thing we need to do is say that this is a compound and this is an element. And as soon as we do that, we realize it's a single replacement reaction. Now that we know it's a single replacement reaction, we need to label our metals and nonmetals. So barium's a metal, fluoride's nonmetal, iodine is a nonmetal. So who is iodine trying to bump out? It's going to bump out the other nonmetals. So it's trying to bump out fluorine. Let's go back to our activity series and let's see if let's see if iodine can bump out fluorine. We go down to our nonmetals series down at the bottom. Iodine's down at the bottom, fluorine's at the top. There is no way that iodine's ever going to be able to bump out fluorine. That's not going to happen. So if this occurs, what do? Well, we simply say, okay, we've got barium fluoride, we've got iodine, and we've got no reaction. And no Rxn is the typical symbol for having no reaction, and that would be sufficient. And right now for practice, I want us to go ahead and write the formulas for our substances over on the left-hand side. But again, just no reaction and we're done. So our last one on our single replacement reactions has copper 1 iodide reacting with chlorine gas. So copper 1 iodine, let's go ahead and do it I'm going to do this in green so you can see that we don't have to do it. Let's do it in words first. We've got copper 1 iodine, copper 1 iodide reacting with chlorine. So the first thing we would want to do is to label. We could start this with our symbols, but I think we'll have more luck if we do it in words first. Chlorine is an element. Copper 1 iodide is a compound, so that's what tells us that this is a single replacement reaction. So now we need to come back under here and label copper as a metal, iodine as a nonmetal, and chlorine as a nonmetal. So who is chlorine going to try to bump out? It's going to try to bump out iodine. Can chlorine bump out iodine? I'm not going to turn to the front page, but if you look back at your notes, you'll see that chlorine is higher on the list than iodine is. It can bump it out. So we're going to end up with a new compound of copper 1 chloride plus now iodine dancing by itself, if you will. So there's our word equation. Now let's redo it in a formula equation. Copper 1 iodide, we've got copper and iodine, and if we look up those charges, we'll see that copper's a +1 and iodine's a -1, so we don't need any other symbols for that, or any other subscripts for that. Plus chlorine, the only thing we need to know about chlorine is it diatomic? And it is, so it will need a 2 after it. It's one of our hydrogen 7. Copper 1 chloride, There's our skeleton. Remember, it's an ionic compound. We've got to find charges. +1 for copper, -1 for chlorine. So again, no subscripts for this one. And now iodine. Iodine is one of our diatomic elements. It's one of the hydrogen 7s, so it does need a 2. Our last step, balance. Get those blanks in front. And you might want to consider doing this in different colors when you do it, just to help you out a little bit, figuring out and keeping straight the balancing process. Looks like we have 1 iodine on the left, but 2 on the right, so let's put a 2 here. 2 chlorines on the left, 1 on the right, so let's put a 2 there. So we've got our chlorines balanced, and look what happened. It also balanced our coppers. So this is the final answer for this particular reaction.